Just for today, everything's okay, everything's okay. Never comes again, another day like yesterday. Just for today, everything's okay, everything's okay.
Good morning, everybody. I'm going to speak on a topic that is pretty broad, and it's maybe a clash that doesn't need to be a clash that I've noticed for years and years and years. I was raised, my father was a biochemist, doctorate in biochemistry, and so our household was fairly scientific in general. And though I've never pursued anything deeply scientific, other than the ways in which psychology brushes up against science, it's a way that I've thought for many, many years, but there's always been this frustration. And I think this sort of connects to a podcast I did earlier where I was talking about people's desire to believe the human desire to believe that the cause of whatever the discomfort is A, simple and understandable, and B, is within their control. And they don't want to consider the possibility that the cause of what they're experiencing maybe isn't in their control. Life is life. We don't have control over everything. Or maybe is a complex number of causes cycling on one another, augmenting one another, canceling each other out to result in the discomfort. Thus, if you were to want to do something about it, it would be too complex to really easily get a handle on. And so the thought for today, and again, something that I've been thinking about for quite a while, is science is a really elegant way of thinking. Like, bottom line, people have all kinds of perceptions about science. Science results in hopefully a fairly objective, measurable field or body of knowledge that's reliable. And that's great if that happens. But at the base of it, science is a system of thinking. It is the human race or human beings going, well, a lot of people might think a lot of different things or perceive a lot of different things. How do we establish what is objectively true outside of any subjective perception of the thing? And that's a beautiful thing. That's an important way of thinking, and it's a way of thinking that has enabled us to develop cars and airplanes and medicine and et cetera, et cetera. And one of the ways that science does this is to eliminate variables, right? So a variable in a situation, let's take health, which is a really obvious example. If you wanted to test whether or not vitamin D, a certain level of vitamin D, is directly related to a stronger immune system, et cetera, in order to prove causation, meaning this level of vitamin D is directly in a causal relationship with this better health outcome. In order to adhere to the rules of science, you have to eliminate the other variables that might be impacting that outcome. So when you design the study to study vitamin D, you're going to have to think about things like, well, someone who reads an article about vitamin D and who decides to take vitamin D and is working on their health, they have a certain mindset, and maybe that mindset actually makes them healthier. Maybe they're more positive and they take better care of themselves, and just the fact that they have a more caring attitude towards self actually increases their immune system. By the way, that's true, right? So that's this confounding variable that mucks up your ability to prove that higher vitamin D levels result in a better immune system or better overall health. Let's say someone who's interested in medical journals showing vitamin D is important, and who says, oh, I'm going to order that and I'm going to take it. is probably doing a bunch of other stuff too. They probably also exercise, and they're probably working on getting enough sleep, and they probably try to eat healthy. So you have these other variables that confound your ability to prove, right? How many people know someone who's like, you know what? I'm sick of the way I live. Like, I want to do this right. Like starting, it's New Year's is coming around, right? My New Year's resolution is I'm going to make it to the gym 3 times a week, and I'm going to do evening walks. I'm going to drink lots of water. I'm going to make sure I'm getting my sleep, and I'm going to eat fruits and vegetables primarily, and a little bit of animal protein, and very light on the carbs. I'm going to do that. And let's say they follow through, and 6 months later, they're really, really healthy. What was the cause? Was it the change in diet? Probably related. Was it exercising? Probably related. Was it their attitude? Probably related. Was it taking walks at night? Probably related. Was it getting better sleep? Probably related. And so you get an outcome, but that person's ability to really talk about that outcome as causal, or as having a causal relationship to a specific thing, is pretty difficult. There are enough studies that there's very clear causal relationship between appropriate exercise and better health, eating healthy and better health, right? But the problem for science, when you talk about, well, why do you do a double-blind study? Why is it that the person who is in the study, the subject of the study, can't know whether or not they got a placebo or whether they got the vitamin D pill? Because perception has a lot to do with it, right? If they think they know what they're getting, sometimes just believing that you're getting something healthy for you makes you healthier. Your body kind of wakes up and goes, yeah, we're doing good things, like this is good, right? So the placebo effect, which is actually really helpful and really important in real life, the fact that you intend well and believe things are going to go well, has incredibly good outcomes for people. But in science, the placebo effect has negative connotations. It's like, well, it's this variable that's very difficult to control for, right? So you do blind or double-blind studies where the clinician who's actually tracking and taking the data also does not know whether that person actually got vitamin D or did not, because the clinician who's studying these things has a bias. Their hypothesis, like when they design a study, they don't just go, I'm just curious what happens if you elevate vitamin D. I have no idea what it's going to do. I don't care. Like, nobody does that. The scientists themselves have a bias. They have an expectation. That's their hypothesis. They hypothesize that given the data that's out there and everything I know and see, seems like there's a strong possibility that increased vitamin D levels will result in a better autoimmune system, better health, right? So the reason the clinician or the people taking the data can't know whether the subject actually has taken vitamin D or not is because there's a tendency for them to skew things or to interpret things or even to dismiss data that counteracts or negates their hypothesis and actually proves that, I'm just making this up, I don't know, right? But I'm just saying, for example, maybe they get data back that suggests that vitamin D doesn't help and that in fact maybe there are worse outcomes. You have no idea how many cases there are in the history of science where scientists actually consciously falsified data because there was so much money in the line and they were so deeply invested, and they'll just convince themselves, no, something went wrong and there was some other confounding variable, and they'll actually falsify the data and make the data look better to prove their hypothesis. Because if they do that, the government or people funding or donating money for them to do this research will continue to give money. But if you do a study and you get data back that says your hypothesis is null, like there's no relationship or even there's an inverse correlation, people with higher vitamin D levels actually have worse health outcomes, your funding's history, not to mention you're going to take a hit on your career and people are going to question, which is not purely scientific, right? If you're purely scientific, you're like, it doesn't matter what, I'm not here to make there be an outcome. If I'm purely scientific, I just want to see what happens and I want to accurately and honestly report what happens. But that's not what happens in science, because science is connected to money and people's egos and people's careers. So with pure science, with clinical science, with laboratory condition science, you have this challenge of, if you're going to reliably establish a causal relationship, not a correlation, right? This is where scientists are always saying correlation is not causation. Meaning, again, the person who's like, you know what, I want to test whether this amount of exercise is really good for me. But they get all excited and they eat healthy too, and they exercise and they're being more positive and they're meditating and they eliminated toxic people and they get really good outcomes. Well, meditating correlates with the good outcomes, meaning it happens in conjunction with it. It's existing in the same environment, but you don't know if it's the cause because you have these other variables that are impacting the outcome. So for science to reliably publish and to say, we have data, we have hard data here that proves that there's a causal relationship between higher vitamin D levels and better health outcomes. For science to be able to do that, it has to eliminate all of these other variables that may correlate but not have a real relationship. Or it might be one of those other variables that created the outcome, and then it's actually the vitamin D correlates. It just accidentally got lucky that it's in an environment where there were better health outcomes, but it was not vitamin D that caused it. So this is the challenge of pure science. This is the challenge of objectively proving something, of, the holy grail of establishing a causal relationship. Because when you establish a causal relationship, there's a bunch of good stuff that happens. You can then leverage that to build machinery, to get a patent, to do more science. Like, at the very least, that data now goes into the body of scientific knowledge that people can incorporate into their studies. And then they go, this is no longer a variable. This has been reliably proven. And I'm taking this as assumption because we don't need to argue about it anymore. And I'm doing a study that just takes as an assumption that vitamin D has better health outcomes, right? So it goes out into the field of scientific knowledge and helps advance science. But also there's a lot of money in being right. When your hypothesis is confirmed and it becomes part of a theory, right? The hypothesis is, I have a pretty educated, insightful guess that increased vitamin D levels correlate or maybe even cause higher, right? And then once you have proven it, and then other scientists have replicated your study and gotten the same results, then at some point it's like, okay, this is now a proven theory and we believe that this is true, right? So when that happens, good things happen to your career. You can also, if you discover something that no one else does and you can convert it into a mechanism or a product, there's millions, maybe hundreds of millions, maybe even billions of dollars to be made. And you can sell that to a company. You can go work for a company that produces it. So there's a bunch of bias and there's a bunch of stuff that happens when you are right, which actually shouldn't matter in pure science. Okay, so you have this challenge, and this has been something that I've watched, and this is something that really incorporates for therapists, and I'll make that connection for you in a minute. That pure science, in order to be causal, in order to establish even reliable correlation, that yes, higher vitamin D levels reliably correlate with better health outcomes. We don't know the mechanism by which it affects that. Again, guys, I'm making this up. I'm not saying this is true. I'm just making up an example to demonstrate how the thing works. This correlates, right? So in order to do that, I have to eliminate all of these other variables. And that can be really good if you are, say, attempting to establish the chemical makeup of a gas planet. There are ways to do that in which you can eliminate variables and then reliably make a scientific statement about, oh, this gas planet is primarily made up of whatever, helium, whatever element. But when it comes to the human condition, science is constantly confounded because, and this is now my argument, I'm saying this, because the very act of eliminating variables pretends that humans do not exist, that what humans experience and what they struggle with and the causes and effects, et cetera, pretends that scientific laboratory condition is relevant. And so again, I'm just making stuff up about vitamin D. I'm not an MD, I'm not a, whatever. I'm just using it to make up an example. This happens all the time with supplements, right? Science will eliminate a bunch of variables and be like, well, there's a strong correlation between X, Y, or Z food. This is a superfood, and we've seen these outcomes. But the human biology is so complex. So what will happen is advertisers will leverage that. It'll be like, it has been shown, they are saying now, whoever they is and what it has been shown, that the element in red grapes or blah blah is like heart protective. But they won't even really know in the complexity of the human gut biome and brain and heart, and their test subjects are human beings who eat other things and breathe air from certain cities and certain areas and are certain types of people, and et cetera, et cetera, et cetera. It would be like, for example, me saying I'm going to do a study on alcohol consumption to make some statements about what is a reasonable or what is a normal amount of alcohol intake and how it relates to behaviors and outcomes. And so this happens all the time. How do you get people to participate in that study? Well, a super easy way, a bunch of studies, especially sociological and psychological studies, it's like, well, these things happen at universities and students tend to be pretty willing and compliant. So you get a bunch of studies that are studying who? College students. Do you think that really represents actually a big picture of what humans are like? I'm not criticizing college students. I'm saying they're at a certain place in their lives. They're at a certain age. Their health is at a certain trajectory in the human lifespan. They have a certain mentality. So for example, in the situation that I'm giving you, if you're trying to study alcohol and you're like, well, let's study college students, well, at least in America, it's like, that's not going to be accurate. College students probably drink an excessive, unreasonable amount, and we consider that normal, and they're sowing their wild oats, and then they're going to graduate college and get a job and find that they don't feel like going to work hungover, and they're going to become more responsible, blah, 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 right? So doing studies, sociological or psychological studies, to me is always really, really frustrating, because to eliminate variables in order to have a scientifically clean study to reliably say, there's a strong correlation, maybe even a causation, requires that you eliminate, that you attempt to correct for all of these complex variables. And I can tell you right now, I was really, really shocked. I went to Pepperdine University for their master's program in psychology. It's a really good program. It's pretty clinical. It's pretty rigorous. I was very glad. I ended up with big student loans, but I'm glad I did it because it was a very rigorous program and I felt really prepared. Sorry, I was up late last night. Memory's not great. I forget what direction I was going with that thought. Oh yes, I was shocked because we had to do lots of research papers. Every class you had at least one research paper, sometimes two. And so you read lots of research. I was shocked at the construction of the studies. And again, I'm not a scientist, like I'm not an expert, but I grew up in the environment and I understand what it means for there to be confounding variables in a situation. And I understand, like, I grew up with a father who, if you talked about anything, would call you on that kind of stuff and be like, well, that's hogwash, blah, blah, blah. They don't know if X, Y, or Z caused it. Like, he just talked that way. So you just sort of grew up being scientifically challenged on anything you thought or said. The studies done where it's like, well, this was all, so who was the population? Oh, it was 15 students. I'm sorry, but that's not even worth publishing. That maybe it's interesting to do it. And look, I'm a therapist and I anecdotally learn stuff, but just sitting by human beings one at a time. And I do a podcast in which I talk about the stuff I learn. I'm not against that. I think it's great. I think humans all the time have to take in data and do some sort of gestalt and figure out what the whole of the thing is and what's a good direction to move. And science has a hard time dealing with that because we just have to. The world is too complex and moving too fast, and there are too many meaningful outcomes that we need to interact with. And we can't wait for science to figure out how to eliminate all the variables and establish a causal relationship, and then wait for the funding, and then other scientists to reproduce those results, and blah, 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 and 50 years later. But you're like, I need to know right now, my, God forbid, family member has cancer. I need to know right now some things that I can do that increase the odds of my family member surviving this. So humans do that all the time. I'm not criticizing doing studies and learning anecdotally, blah, blah, blah. But it's not really that kind of science. It pretends to, it tries really hard. It pretends to be that kind of science where it's like, well, we establish this correlation and you're applying statistics. And by the way, statistics has developed to such a level that you can even use statistical models to help eliminate the impact of some variables. So math and science, it's amazing. Like, you really can elegantly reduce the impact of some variables. But in the end, it all comes back to the human condition is way too complex. So the point that I'm making today in this particular podcast is to say, we have to accept that there has always been and probably will always be this constant tension between pure science, which, if done correctly, can establish a strong correlation between a possible cause and effect, or an actual causal relationship, which is very, very useful to the human race. But that in the doing of it, science has to eliminate so much of reality that sometimes it becomes almost irrelevant. It's almost like that's just going to get used to sell us an over-the-counter supplement that doesn't really interact the way you say it interacts. For example, again, I was going back to things like prebiotics and probiotics or vitamin D, or 5-HTP supports the production of serotonin, blah, blah. But true pure scientists who get into that, if you talk to them, they'll be like, well, there's a lot of hemming and hawing that's really frustrating. But the reason they do that is because they know that the process that chemical or supplement that you bought, the process it goes through, there are so many conversions of proteins, amino acids, and things that can happen in an individual, and things that happen differently in different genders, and things that happen differently in different races, and depending on where you live, and depending on the kind of water you drink, and the air that you breathe, and what you do, and whether you exercise, and blah, blah, blah. And different bodies have different processes, and some bodies don't do well at this process, and blah, blah, blah. There's so much complexity that's why real honest scientists are really frustrating, because they will almost never commit to saying anything, because they know that even though a study may have reliably, it may have been elegantly designed, it may be ethical, and it may have reliably recognized that there's a strong correlation between thing A and the outcome, they know that it's still very difficult to make an assertive statement that goes back in and stays true in all the complexity, because in all the complexity of what real life is, those variables that they eliminate to do the study all exist. They don't go away, and they're acting on you, and they're acting on your experiences, and they're acting on your interactions and on what you take, et cetera, right? So I'm using the example of medicine or supplements, but this applies to almost everything that relates to the human condition. Everything is really complex. So science has this challenge. If you eliminate the complexity so that you can reliably study a causal or a correlation, you've essentially removed the reality of reality. And so you can say something about that isolated thing that you're studying. But when you introduce that isolated thing back into the complexity of reality, you have to be super, super careful, which is why scientists say things like, there's a strong suggestion that, substance A may play a part in an important pathway that results in significantly higher serotonin levels. And the consumer is just like, just tell me whether I should buy it or not. Can't you ever say anything straight? No, they can't. The only people who say things straight are the people selling it to you. The only people who say things straight, who are like, hey, the data is really clear on this. This is really healthy, blah, 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 and you need to be taking this. Okay, so let me back off a little bit. There is stuff, right? Science has established things. Medicine, there are things that are established, right? So I'm not saying that you can't rely on anything being true. But what I'm saying is, we need to understand as consumers and as human beings in the human condition that the complexity of you as an organism and your brain and your environment and psychologically how you interact and how you respond, and the fact that just believing something changes outcomes. Just believing something changes outcomes. How complex is this? We need to understand that there's a massive portion of anything that's being sold to us as the solution to the problem are just people telling you what you want to hear, that there's a clear, that this is so good for this toothpaste is so good for you. There are some people who just swear by apple cider vinegar. And then I just saw a doctor the other day say, well, it can be, but for some people it's actually really unhealthy and it does, like, the only people speaking absolutely clearly and with total assurance that substance A is the best thing ever are people selling it to you, or people who are sold on their own position as a knowledgeable person. I'm this person, people who like to hold forth and get up on their soapbox and say, well, it's very clear, if you really want to exercise better, it's very important that you take creatine. Probably. Again, I'm not actually saying yes or no to this. I'm just using it as an example. There are people who love to talk that way. They're not even going to take your money. What they're taking is the ego stroking. That they are taking this feeling that they're an authority, that they've accumulated this knowledge. If they're speaking that assertively about it, they're not an authority. They're not. Because those things are way more complex. So to put a button on it, to put a pin in it, there's this constant tension between pure science attempting to objectively establish that there's a correlation between one thing, and the outcome, one variable in the outcome. And it does this by eliminating all the other variables so that nothing is messing with the causal relationship. So if there is a causal relationship, you can say without fail, hey, there was nothing else interacting with this process, therefore chemical A caused outcome B. They have to do that to reliably establish an objectively measurable thing that they can then report and publish and say, hey, this is reliable. And the reason real scientists who are honest, are so mealy-mouthed about how they talk about the stuff, even when a study has said, yes, there's a very strong correlation, is because they know that they had to reduce and remove all the complexity surrounding that phenomenon in order to establish a causal relationship or a correlation. And in real life, the complexity is not removed. And so they know that there's going to be years, decades, maybe hundreds of years waiting for new findings that can help them design new studies before they can really say, this thing has a strong correlation, this is reliable, this is probably not going anywhere. And so what that means for you is when you hear, especially you hear this on the news, the talking heads are the worst. You know, scientists, made a stunning new, anytime they use that language, stunning new discovery, a shocking, right? This happened about 10, 15 years ago. Everything became shocking. And a shocking new discovery that blah, 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 blah. Yeah, bullshit. If someone is using that language, they have no idea what that thing is. They're just reading copy. Shocking new discovery. You know, how many superfoods, like, oh, this thing is this superfood, like unbelievable health outcomes, and then there's another one, and then there's another one, then there's one that's like way more than blueberries, way more than acai, way like, yeah, because the people saying that either like the position of talking like an authority, they like talking like they have a close relationship to the scientific community, they like talking as if they are kind of a scientist themselves, or they're selling you something. Now, I do this, you and I do, we all do this, right? It creeps into the language and creeps into how we think, and we don't have time to test everything. So I'm not criticizing or saying that you should be able to sort through all of this stuff. But we need to start from the position of understanding this massive, unresolvable tension between pure science, which eliminates the complexity of life in order to establish a causal relationship that can be published, right? And real life that is super complex, constantly cycling on itself with sometimes variables or causes that we don't even know exist. Did people, 10,000 years ago know that solar flares could have this dangerous impact on electronics? This didn't know. That information didn't exist, right? So there's this tension between what real life is, and there's this frustration when you're part of real life trying to make decisions, trying to use science. And you need to understand that when you try to use science, it may put you in the right direction. You may be able to stack the odds in your favor of good outcomes. If you pay attention and if you're reasonable and you don't buy into shocking new discovery, revolutionary new, like if you don't buy into that and you just accept the fact that you're going to need to act like a scientist, read through some studies, actually go to the source and go, what did that study actually say? What did the scientists actually say? And it'll always be less committed and more confusing. That you won't know for sure, but that it's healthy to try to move things in a direction that's good for you. And there are some things that are pretty sure. Reasonable exercise is very healthy. A positive attitude is very healthy. Good sleep is very healthy. So there are some things that are reliable, that are pretty simple, that have been obvious and been there for a long time. There's still it's still a debate whether meat is good for you or bad for you, and carnivore diet, et cetera, and it becomes more and more clear that it isn't about meat or vegetables or fruit. It is whether or not they are unhealthy versions of the thing, or whether or not the people who are eating that thing have an overall unhealthy lifestyle, right? They did those there was that period of time where it's like, well, red wine's good for you. Well, the truth is, anything with alcohol in it is far worse for you than any small benefit you might get. But they were saying that because the French and the Italians have much better heart health. This is a perfect example. And so everything was like, red wine, you should drink red wine. Bullshit. They come from countries where people walk all the time and where they're way more strict with preservatives and chemicals in their food. Their food is much cleaner and much healthier overall. I didn't do a study. Maybe it is red wine. There is an element in red wine that's actually a little bit protective. But again, anything with alcohol in it is far worse for you. It's sort of like taking cyanide and going, yeah, but I took it with a vegetable, so I'm healthy. It's like, no, that's not good. If you're wondering whether you should drink red wine or not, the answer is you shouldn't drink any alcohol ever. It's not good for you, ever, in any amount. But people who drink reasonably every other week and just have a little glass of wine with dinner and enjoy their family, there's a whole complex situation going on. They have a certain mindset. They're a certain kind of person. They're a reasonable person. They have a good connection with their family. They said things that therapists know are true. Healthy, relaxed, loving relationships are massively protective and actually increase your immune system. Those things are true, right? So it's not that someone who has a glass of red wine once a week, it's because of the red wine. It is because they are the kind of person who lives a healthy life, right? The French and the Italians were living a much healthier lifestyle. And we went, oh, it's because they're drinking red wine. Don't be silly. Alcohol is not good for you. I drink it sometimes, but it's not good for you. Don't kid yourself. So that's the constant tension. That's the constant tension. The next time people show up and they're like, oh, red wine is good for you, or whatever the new thing is, like there's been, this established this relationship between whatever and brain health or blah, blah, blah. Yeah, maybe. But always remember, ask yourself, the people they studied, those people have habits. They didn't put those people in a test tube and control everything they did for 6 months to see their outcomes. Those people still go home and live the kinds of lives they live with a crap load of other variables impacting whether they're a healthy person or not. So this is the constant tension between pure science, objective science, publishable science in that way where there's this reliable correlation, and real life. And as a therapist, and I think therapists in general, we get frustrated with this, right? Because this is a similar relationship between therapy and the medical community. And supposedly we're part of the medical community. Insurance tries to treat it like they won't even pay if the DSM diagnoses are a way of making it medical. Any good therapist knows it's absolute bullshit. The complexity, right? Oh, this person has a chemical brain state that correlates with the experience of being severely depressed. Yeah, that's real, that exists, and you can consider that medical, but I promise you the causes of that person's depression are wide and varied, and each person being depressed in certain ways has to do with beliefs, has to do with how you were raised, has to do with genetics, has to do with environmental insults, preservatives, what you eat, how much exercise you get, whether you sleep adequately, what the environment is like, whether the environment's overstimulating. Every therapist knows that this is how complex it is. And this is what we deal with when we're working with people. And then the medical community will just show up and go, well, there's a chemical imbalance and you need this. Cool, I love medicine. Super important to have a more pure science. And I will go to the doctor and go, doc, this is going on. Like, can you help me? What's going on? And at the same time, don't kid yourself. Life and humans it's way more complex. And that's what therapists deal with. When someone comes into the therapy room, you're dealing with someone who loves complexity. Therapists should love complexity. If you go to a therapist who's too linear and purely scientific, who's just like, well, we notice that people who are depressed tend to have this belief system, and they start talking to you like just unbelieve these things and problem solved. That's not a good therapist. They have no idea. They can't deal with the complexity of what the human condition is. So that was my thought for today. It's something I've thought about a lot over the years. Sometimes I get really frustrated at the way science gets gamed. It's not science's fault. If you're going to objectively establish something, you need to eliminate variables. It's not human beings' fault. We have to move through life and make decisions and seek outcomes when we don't have enough information, and we may never have enough information, reliable information, and we have to kind of rely on science, medicine, authorities, whatever. It's okay. Just never, ever, ever, ever let go of that deep tension between the fact that real life is so complex and in so many ways mysterious, and that science attempts to remove the mystery, but in the removing of the complexity of it, when they find a reliable answer, they have found something that may not be very significant when you reintroduce it into the human condition. This is why in the supplement industry you see first it's like, oh, vitamin D. Then it's like, oh, if you don't take vitamin D with, I forget which one it is. It's like, I think it is maybe vitamin D. If you don't take it with vitamin K, you can't absorb it. Or like, and then it's like, oh, if this neurotransmitter isn't present, and if that isn't present, and if you have this kind of gut biome, and yeah, because it's complex. It's complex, and it will always be complex until we get turned into cyborgs. All right, guys, that was my riff for today. I enjoyed it. My wife and I had a company holiday party last night, so I did in fact have a couple drinks and feeling a little fuzzy. So I hope I was able to make the point okay, but I enjoyed it, and I hope you guys have a wonderful day, and I will see you next time. Take care.
Just for today, everything's okay, everything's okay.